Hi, this is Dr. Taft, and we are going to talk about data wrangling in Excel today. So by data wrangling, I basically mean the kind of process that you did when you were dealing with the survey questions in the Making It Personal lab. You take inputs and you sort of fix them so you're not changing the information content, but you are organizing the information and formatting it so that your statistical program can understand what's going on. And that ends up being a really important and common task. So I'm going to talk about a couple of different aspects of data wrangling. And the first thing I'm going to talk about is formatting, which is super boring but useful. So the first thing that I want to talk about is plain text data. So there's a lot of different kinds of data formats where the file contains information that a specific program like Excel or SPSS can use to figure out what's going on. But plain text doesn't have any of that. Plain text is just letters and numbers and symbols in, like you would say, with a text editor. It's not even as complicated as what you get with Word. So there are two kinds of plain text data that you often encounter. One is a delimited plain text, in which case each column is separated by some kind of specially used character, which is usually either a comma or some kind of white space, like a tab or a space itself. And so an example of plain text data is down here. So this would be the entire contents of the file. So you have the first row is going to be the column names. Each column name is separated by a comma. So there's comma, comma, end of line. And then each successive row also has the same format. So there's data, comma, data, comma. So you can see that this first column has text, and then the other two have numbers. There's nothing in the file to tell the statistical software that that's the case. It's going to have to figure it out itself. But at least it can figure out what stuff goes together. The other kind of format is called fixed width. And sometimes it's a little easier for humans to read, but it's not always easier for the computer to read. So for example, in this data here, each column takes exactly 5 characters, right? So word plus a space, then order, and no space, and then length, right? So there's no space at all. You don't need any space. You just say, okay, we've used 5, so we're on to the next one. And then in here, the number 1, and sometimes fixed width, the 1 would be over here, sometimes it would be over there, sometimes it would be in the middle. It doesn't really matter exactly where in this range it goes, as long as it's there somewhere. We don't tend to use fixed width very often because of a variety of reasons. For example, if we had a word that was 6 letters long, we'd have to change the width of every column, and ain't nobody got time for that. So generally speaking, we use delimited. Tab and comma delimited are the most common. I personally prefer comma delimited, so we're going to use comma delimited or comma separated values every time we need to deal with plain text in this course. And one of the advantages of plain text is, even though it is requires a little bit more shepherding through the import process, because the computer doesn't know, for example, this is text and these are numbers, this kind of input can work in just about any kind of statistical or spreadsheet program. And so you can communicate across different platforms with it. The other kind of formatting that I want to talk about is scientific notation. Probably is a review, but if it's not, we'll just talk about it briefly. When we're writing numbers with many zeros, keeping track of all those zeros is boring and also prone to error, especially if you're typing it. So scientific notation abbreviates those zeros by just writing the number of how many there are. It does this, and that's basically the exponents of the power of 10 that you're multiplying it. So you can think of taking a number like 1 millionth, which in decimal places is this, and then you write it as 1 times 10 to the negative 6th. So e minus 0.6 is equivalent of 10 to the negative 6th, so 1 divided by 1 million, which is 1 millionth. So negative exponents mean things that are less than 1. Negative numbers in the exponents don't mean less than 0. And 1 million will be 1e positive 6. So even though the only difference between these two representations is a minus or plus, these numbers are like a quadrillion. This one's a quadrillion times bigger than this one. It's a lot. So there's a huge difference in just one symbol, and that's one of the advantages of scientific notation. It's a very compact way of representing many different values. If you do have a negative number, like here's pi, so negative pi would be minus 3.14, and we're just rounding it to 3 significant digits here, and then it's supposed to be E0, and it could be plus 0 or minus 0, doesn't matter. That means there's no zeros in before. We don't have to move this decimal place, basically. So if you look at I put the comma in the wrong place. 12,346,789 in scientific notation. That is 1.2345678 e to the 8th. I think that actually should be e to the 7th. That's annoying. Type that into Excel and it'll probably be 1.23 e to the 7th. I'll change that in a sec. And then finally, 1 over 42 million in scientific notation is minus 2.38, and some other junk, e to minus 7. So one of the things that's important to note is that you have some numbers near the decimal place here, which give you a sense of the details, and then this e tells you sort of what we call this the order of magnitude, is what area on the number line you're on. And so again, it's a very compact way of expressing it. So that's formatting in Data Wrangler.